Alrighty, so now let's start talking about experiments. The first half of this unit was devoted to observational studies, random sampling methods, and bias. But now we're actually going to look at what it looks like when you apply a treatment to some individuals and what we can say about these results. So, some vocabulary here. First off, an experimental unit is the individuals or objects who are randomly assigned treatments in an experiment. Now, if these individuals are humans, then they are often called subjects or participants. And this goes to show you that experiments aren't only done on people. You can do them on plants, you can do them on objects, cars, etc. Now, treatments are the levels or combinations of levels of the explanatory variable, oftentimes referred to as the conditions applied to experimental units. Who gets what, and we'll talk more about that in the examples. And then lastly, the response variable is the outcome of an experiment that is measured after the treatments have been applied. Oh, and I guess my word applied got cut off there. Whoopsies. Alrighty, now, a well-designed experiment can infer cause and effect, and the following elements must be included. And each of these elements serves a purpose into experimental design. So the first one is the element of comparison. And we have to compare at least two treatment groups, one of which should be the control group. So you can compare, it needs to be at least two, up to however many different treatments you've got going on. But of course, you don't want choice overload. You actually, you want to compare a few treatments to see which of those was the most effective. The next element would be controlled, which this could address potential confounding variables. And this is also referred to as the zero group, meaning that it's the original treatment or maybe the inactive treatment. The next element we need is random assignment of treatments to experimental units. And the last element is going to be replication, more than one experimental unit in each treatment group. So CCRR, yeah, I got nothing for it. But those are typically the four elements that you're going to need. Now, each element serves a purpose. So for example, comparison and control allow us to see how each treatment group is responding by providing some form of a baseline comparison for the effects of the treatments. Meaning that I can compare the new formula to the old formula. I can compare the placebo to the other two dosages of pills, etc. Now, sometimes if you receive an inactive treatment, this is what we call a placebo. And this is used in order to determine if the treatment of interest has any effect. Meaning that if someone experiences the placebo effect, this occurs when the experimental units respond to the placebo, essentially creating a false positive. Typically, this would be participants that are experiencing the placebo effect. They feel like they're getting better because they think that they're getting better, things like that. So control is just that baseline, that zero group, and for an even better experimental design, you'd want to use a placebo, which is an inactive or fake treatment. Now, the next thing that we need is random assignment, and this allows us to infer cause and effect because it's going to balance out the effects of confounding variables into these different treatment groups. So if we truly randomize and we get all of these different groups formed, hopefully because of that randomization method, we've limited the bias that would be introduced, and we're going to reduce these effects here of confounding variables so that they're balanced out through this random assignment. And lastly, replication ensures that there are enough experimental units are used in each group so that the differences in each of the treatments can actually be distinguished from chance differences between the groups. Meaning that I'm doing this enough times to make sure that there actually are differences in the treatments, and it's not just because each of the groups is different from one another. So again, this idea of reducing variability when we're collecting the data. Now, some other things to take into account are what we call blinding. A single blind experiment is where subjects do not know which treatment they are receiving, but the members of the research team do, or vice versa. Meaning that I'm going to give you a pill, you don't know what's in that pill, you've just agreed. That's a single blind, I know, but you don't know. Or we can have a double blind study where neither the subjects nor the members of the research team who interact with them know which treatment a subject is receiving. There we're completely like, I don't know, you don't know. Usually there's a third party who does know because we can't just leave it all to chance. But adding these elements of blinding is super effective because that way we can reduce the effects of the placebo, or we can remove or reduce the effects of any of my personal bias that I've introduced in collecting this design, or this data. Now, the most basic type of experiment is called a completely randomized design. And we're actually going to take a look at an example here of the different ways they might ask this on an AP exam. So, for example, a health organization wants to know if a low-carb or low-fat diet is more effective for long-term weight loss. In addition to those diets, some volunteers will be provided with only a brochure about healthy eating. the organization decides to conduct an experiment to compare these diet plans. 90 volunteers agree to participate in the study for 1 year. Okay, so things we need to identify here. The experimental units are who are receiving these treatments, and that was given in our last sentence here. This is going to be 90 volunteers. And notice this could be a case of voluntary response bias, so I'm not going to be able to generalize to all adults. I'll only be able to generalize to those that are similar to these 90 volunteers in the study. Now, the treatments we've got going on, we have a low-carb diet. We also were told there's a low-fat diet. And it's tempting to say those are the only two, but we were also told some volunteers will be provided with only a brochure. So that's going to be our control there, is that there's actually no active treatment there, it's just a piece of paper. And lastly, what am I measuring in this study? Well, I'm measuring long-term weight loss, but I'm not just measuring long-term weight loss. I'm measuring long-term weight loss for 1 year to see which of these treatments was in fact most effective in this long-term weight loss. So now that we've got that, we need to kind of lay out this design. So there's a little bit of drawing that's involved with this experimental design, which I think is kind of fun, just so you can see the visual element here. So here's, oh, sorry y'all, dog's barking in the background. One quick pause. All right, sorry about that, y'all. So let's actually design our randomized experiment. So our starting point was the 90 volunteers. We started here. Now, within these 90 volunteers, I have 3 treatment groups. So the first one is going to be the low-carb diet. And since I have 3 treatment groups, I'll put 30 people there. Here, I'm going to do the low-fat diet. I'll put another 30 people there. And then here, I'm going to have the brochure, which I'll put another 30 people there. And from there, I'm going to compare the long-term weight loss. Long-term weight loss. Now, I've got my control, right, my brochure. I've got my replication, because there's at least 90 people and 30 within each group. I've got my response variable. But this question here of random assignment, I need to figure out some way where I can randomly assign these 90 volunteers into each of these groups. So I have to ask myself, where should I put the random assignment? Well, that's going to go right here in each of these branches. So I'm going to denote my random assignment using this. And on the AP exam, you're going to need to indicate what you're doing. That ensures that the groups are of equal number, that there's some use of randomization, and that the groups are roughly equivalent. So I've got 3 outcomes. I could roll a dice. I could write all their names on pieces of paper, put them in a hat and select. I don't want to ask them which group they want to join because then voluntary response bias. So let's just do the simple one. So let's let us obtain a list. See, I'm thinking on the fly here. Obtain a list of all participants. Actually, sorry y'all, I'm going to cheat here. I'm going to type this out. So here we go. We are going to obtain a list of all volunteer names. Write each name on a flashcard. Place all 90 cards into a hat. And we're going to mix well. Now we're going to randomly select 30 names for the low-carb diet. And we're going to repeat this process for low-fat diet and brochure groups. Brochure, why does that word look so weird? All right, so let's take into account here. Did I have some element of randomness? Well, I'm randomly selecting and I'm mixing them well in the hat. I know everyone who's in the group flash card. I place all the cards into a hat. I mix them well. Hopefully randomization works in my favor. And then I'm going to randomly select these 30 names. That's going to be my low carb diet. And then I'm going to do that again for my low fat and my brochure group. Now the only issue I see with my response here is that I didn't indicate that I'm going to, let's see, repeat this process for low-fat diet and brochure groups. I think that should be enough to indicate, like, hey, from the remaining names. Yeah, so let's just add that in. From the remaining 60 names. Repeat this process. Boom. You know, you never want to give them room to take away. And so this is a very weird concept. So we definitely want to practice our random assignment and just go through and reread it. It should be clear enough to where someone who doesn't have a statistical background should be able to carry out your procedure. So I think someone could get 90 flashcards, write names, mix it into a hat, pull out 30 names for the low carb, low fat, and our brochure groups. That seems pretty straightforward there. Now, is there a control group in the design? Yes, there is a control group, which is the brochure group, because they receive no active treatment. So let me do my checklist here. Did I answer the question? Yep. Is there context? Yeah, I have a control group, a brochure group, and in this experiment. And then what's my explanation? Well, they are the control group because they receive no active treatment. We call this the ACE model, to ACE FRQs on the AP exam. You need to answer, context, explain. Lastly, is replication used properly? I'd argue replication is used properly. And why would that be? Well, yes, replication is used properly since there are 90 volunteers and 30 volunteers in each treatment group. Any differences in the results could be attributed to the treatments and not the chance differences in the groups. And again, I'm just copying what we wrote down on the first page, right? This, all of these concepts. And lastly, what is a potential confounding variable in this study? Well, if I'm looking at long-term weight loss, something like health status, and health status would be confounded with, maybe healthy people are already engaging in diets, so weight loss could be influenced by this. Maybe age, maybe younger people are more active, so their weight loss could be easier, and the same goes for maybe older people are less active, so their weight loss could be more difficult. Maybe gender identity, maybe different genders respond differently to the low carb, low fat diet, etc. So you just have to pick one confounding variable and just explain how it's related to the explanatory variable, how it's related to these diets, and how it could influence the weight loss. So that's just a typical example of what you might see on an FRQ question or even in a multiple choice question. So just knowing all the vocabulary is super helpful as you're identifying each of these elements. The next example here actually comes to us from the 2019 exam. We're going to do this in class together. And we're going to use a rubric to actually grade one another's responses just so we get that practice. But you can see there's usually the structure of like identify some element in the experimental design. Then talk about that element, control, comparison, replication, random assignment, and then do something about it, design the experiment, describe how you'd randomly assign, etc. Just things like that. So you just got to be well versed in these ideas. And what were the ideas of this lesson? Well, the most basic type of design is a completely randomized design. We start with our volunteer or our participants or objects. We randomly assign them to treatment groups, and then we compare those treatment groups. So we need compare, control, replication, random assignment. There's types of blinding. Maybe you don't know which treatment you're getting. This is a single blind, or maybe you and I both don't know. That's a double blind study. And then lastly is the placebo effect. Maybe I give you an inactive treatment or a fake treatment and you actually respond, even though you should not be responding to it because there's no active ingredients. You just think you're getting better. So that's the basic principles of experimental design. So in the next lesson, we're going to talk about some more developed experimental design. So stay tuned for more experimental design.